Explore Pragmatic Institute's training to help your organization become data-driven. Our courses provide teams with the hands-on practice and skills they need to leverage data for business success. Visit pragmaticinstitute.com/data today. Welcome to Data Chats, a podcast by Pragmatic Institute and the Data Incubator, where we tackle data topics and trends with experts, industry leaders, instructors, and alumni. I'm your host, Chris Richardson, and today I'm sitting down with Eric Siegel, founder of the Machine Learning Week conference series, former Columbia professor, and best-selling author of Predictive Analytics. He is now coming out with a new release from MIT Press called the AI Playbook, Mastering the Rare Art of Machine Learning Deployment. Eric Siegel is a leading consultant who helps companies make machine learning understandable and captivating. He is also a second-time guest, so I'm very happy to have him back on the show. Thanks for joining us today, Eric.
Thank you very much, Chris, for having me.
So maybe people have heard our previous interview and maybe not. So for those who haven't, can you give us the quick summary of sort of what you've been up to and I guess what brought you here for this second book interview?
Well, I've been a consultant in machine learning for 20 years. I've been in the field for 30. And I've been most recently working on this new book that's about to come out, as you mentioned, the AI Playbook, because I've become kind of concerned with the degree to which there's a lack of returns in machine learning projects in the industry. This is the hottest technology. It's the most powerful general purpose technology, but the hardest to use.
Yeah. And I think that's something I've heard. And that's probably one of the differences in when I'm talking to people who are, reading news articles about AI, these kinds of things, very excited about the future. And then when I'm talking to people who are actually doing it, there's often, while there is that excitement, there's often a much more sort of skeptical look at how these things will actually be deployed. So can you say a little bit more about that, especially for people who maybe don't have that kind of experience where it seems, at least in reading news coverage, that once you have a good AI system or even just a simple sort of machine learning algorithm, what would stop anyone from using it? Like, why would there be this bottleneck that anyone in the industry, I think, has probably seen many times?
Great question. Well, there's nobody stopping anybody. There's nothing stopping people from using the algorithm. The problem is that the product of the algorithm, a predictive model, which now has a lot of potential value, the organization won't actually capture that value and realize its potential value unless they deploy it, unless they actually change business as usual, that the existing large scale operations are actually affected by the predictions of that model on a systematic basis. So that's a change to business. It requires a very specialized change management process. And since most organizations don't quite realize that today, the excitement, the hype is about this core technology. And that's why I got into it originally. It is really cool to be able to learn from data, to draw generalizations from some maybe large but finite number of particular historical examples and draw generalizations that apply in general, that apply in new situations. That's obviously got a lot of potential value. It's really, in my opinion, the coolest kind of science or technology. But the focus is on that core technology. It's like we're fetishizing it and we're more excited about the rocket science than the launch of the rocket. There needs to be a reorientation around these projects that are deployment oriented and oriented towards actually capturing that business value.
Yeah, I love that analogy too. And in the book, one thing that stood out to me that seems so obvious, but also, when you said it, I kind of had an aha moment, or when you wrote it and I was looking through it, is that all these data scientists who are brilliant, maybe trained in multiple disciplines within artificial intelligence and things, they tend to get series of numbers or data or whatever, and then they do these amazing things with it, and that's their training. So what's wrong with that? Can you say a little bit more, or maybe what's lacking with that?
Yeah, there is something lacking. They're too smart for their britches, right? They're focused just on the core technology. There needs to be a little more holistic view. The book, the AI Playbook, presents a new business paradigm that I call BizML. So it's a business playbook for running machine learning projects end to end from inception to deployment so that they actually successfully integrate, deploy, operationalize, go into production. Those are all the same thing. That's the lingo. That's the term. Those are the terms of art. Get it to actually move the organization so that value is actually captured. Data scientists typically are trained to focus just on that core modeling piece. But if they want their work to actually manifest into achieved and captured value, they need to take a more holistic look. So do their business side counterparts. So the theme of the book is that we need to get a well-defined, well-understood, and broadly known about standard paradigm that I've formalized to the degree that you can formalize an organizational process rather than a technical one into this 6-step practice in the book called BizML. And that everyone needs to get on the same page and that the business stakeholders need to be heavily involved in each of the 6 steps from end to end, collaborating. And the business side stakeholders also need to sort of expand their view and ramp up on semi-technical understanding. And here's the bottom line. It's really simple. Business side stakeholders need to understand what's predicted, how well it's predicted. So what are the numbers, the math, the metrics that are pertinent to sort of reporting on how good the model is? What's predicted, how well it's predicted, and then what's done about it, how that's actually integrated, the output of the model, the predictions, the probabilities. This is about systematically, any machine learning project, if it's going to realize value, ultimately it's about systematically acting on many probabilities that drive individual cases, individual operational decisions, such as which customer to contact, which transaction to audit for fraud, which credit applicant to approve, et cetera, which ad to display. All the main large scale operations that we conduct have potential to be improved. And that's the end goal. Now, most people in technology know that there needs to be an end goal. There needs to be a business objective, but that's literally only the first of 6 steps. So knowing that is a good first step to say, hey, we're oriented on value, but you got to get more precise and you need to involve the business side stakeholders on a certain level of semi-technical detail, more than just say, hey, we're going to use this to target ads. It's got to get a lot more precise. Exactly what's predicted, which customers who've been around for more than 30 years are going to respond to this marketing with a purchase that has margins of at least 20%, not including shipping, et cetera. So you have to hone it down to a very specific prediction goal that aligns with the business objective, because now once we've pursued that prediction goal and we have probabilities that align with that very particular prediction goal, now we know we can use it. There's been that buy-in and understanding from the get-go, from the inception of the project. So now when it gets to deployment, and this is the meat of the matter, yes, the core rocket science, so exciting, awesome, fine. But the meat of the matter, the only way that's going to be value is at that point where you actually trigger into deployment and you're changing business operations by acting on those probabilities. Probabilities of what? What's being predicted? Some long, very specific prediction goal. Only semi-technical. This is not the core rocket science. It's about how to use that rocket science in a way that's effective for value. So that's the theme. We need to ramp up business side stakeholders, involve them, and bridge this gap that's routinely not bridged. And therefore, routinely, we see that projects fail to achieve value-driven deployment.
Yeah. And so to jump into a few of those details, let's say you have, some kind of predictive analytics that the model has been created. It seems, at least from the early stages, to be really valuable in the sense of, let's just follow along with like targeting specific ads to specific people. So before deployment, we have an algorithm designed by some in-house data scientists who are pretty confident that they can target the right people with the right ads better than what's currently happening. That seems like a no-brainer, just like, let's get going. Also, though, it seems, as you say in the book, different than something like a light bulb, where if you were to create a light bulb and turn it on, you know that you have a working light bulb. Whereas here, this may not see any kind of significant increase for, 6 months or something, depending on the kind of business. So there are issues in terms of like actually knowing that something that seems good on paper or on the screen is actually going to be valuable. And then there's the actual act, as you said, of adding that value to the business. Why doesn't that happen in the majority of cases?
Right. I mean, I feel like you kind of answered your own question there. I think you're alluding to, there's a place in the book where I say, the innovation known as machine learning deployment is fundamental. It's huge. everyone's trying to jump on this bandwagon. And that innovation is to improve large scale operations. That is to say, systematically act on probabilities to improve over large numbers of cases, the operational decisions that are being conducted, millions of times a day by large enterprises and medium-sized enterprises, anything at some level of scale, on some level of granularity, lots of cases. So yeah, innovations like a light bulb are really intuitive and lay people get it. You flip the switch, you push send on an email message. You can see that they received it in each individual case. But with this innovation, it's a little more abstract because you can only see the results and the benefit, the win, the value by aggregating those wins over many cases. Because sometimes the machine will be wrong. We're not clairvoyant. We can't expect machines to be clairvoyant. We can't expect magic crystal ball levels of precision and confidence in these predictions, but they can predict much better than guessing and other simple baselines. And that pans out. How well does it pan out? You have to measure it with arithmetic. What arithmetic? It depends on the project, but that's the second of those three things that I'm espousing. All business stakeholders need to understand what's predicted, how well, and what's done about it. How well alludes to the metrics, the way you define. And usually people talk about the word accuracy, and that's usually a red herring. It's usually impertinent and misleading as far as any particular business use case where you're deploying this thing. It's not about probability. It's about how much you're predicting better than guessing. One measure is called lift, but ultimately what you really want to do is translate the model's sort of pure technical predictive performance into business metrics like profit, number of customers saved, the things that matter directly and are meaningful to the business stakeholders. So that's another big missing ingredient, is that people are not speaking concretely and bridging that gap. What exactly are we going to measure? Why? What matters to the business? What resounds with the business stakeholder? That is to say, the data scientist's client, the person in charge of the large scale operations that are going to be improved, the person who ultimately has to buy in and weigh in. And by doing so, that when you finally get to that big culminating part towards the end of the project where you're actually going to deploy, they don't get cold feet, as so often is the case. They don't hesitate. They've already really bought in and understood on that level of semi-technical details, and it's going to be greenlit. You're going to actually deploy. So many times at that point, the stakeholder turns out they're really not as ramped up as you thought that maybe they should be. If you're a data scientist, you're looking at the stakeholder, you're thinking, I think they get it, but they don't, because you're taking a little too much for granted about what they might not understand. Okay, this thing, how am I supposed to trust this thing that's not predicting like a magic crystal ball? I understand that it's predicting better than guessing, but how much better than guessing? How do I put a concrete number on that? We've got to bridge that gap. And the way you do that is, chapter 3/step 6 of the process, BizML process, which is establishing those metrics in a way in business terms that are understood and concrete and mean something, so that we know what we're measuring, what we're going for, what business value we're going to be able to potentially achieve with the model.
Yeah. So, you've already mentioned a bunch of factors as to why even something that looks great and that probably would be very effective can get stopped or can get slowed down significantly. The issue of translating it into basically profit in most organizations, the issue of actually rolling out these changes that can be significant within an org structure. I'm thinking, going back to those data scientists who, create maybe some brilliant algorithm or create some kind of machine learning training that they're very happy about. If they're listening to this, I can imagine maybe the more skeptical of them saying to themselves, at least, I'm a data scientist. I'm not a change management consultant. I'm not an operations, VP. I've given like a great algorithm. I've given a great process for learning for this machine learning project. That's my job. What would you say to that? Is it a different role, or is it something that data scientists have to start changing or thinking about differently in their roles?
Definitely data scientists should change and expand their holisticify their advantage on their own role, but they don't all have to. There is such a thing as a data scientist who's literally just doing some number crunching. But unless you're at a very large organization and you really trust that there's a process in place to handle all these echelons I'm alluding to of the practice needed for end-to-end to reach deployment successfully, somebody's got to take initiative, and it could be anybody. So what you're referring to is sort of half of this sort of two-pronged problem, which is that both sides kind of typically consider it the other's responsibility. The
Exactly.
data scientist said, well, I make this model. Of course, it's a no-brainer. Its value is self-evident. Of course, it'll get deployed. And if the organization doesn't deploy it, that's some kind of operational snafu. That's not my problem. And it's not my responsibility. Whereas the business stakeholder, when they start to get the sense that there are these, and now I'm putting it on the table, I'm saying there's this semi-technical stuff you need to learn. Now, it's not the rocket science. You don't need to learn the ins and outs of the machine learning algorithm or even the nuts and bolts of how the model actually calculates probabilities. It's nice to have a sense of that. It's cool. Just like I know about internal combustion, about how an engine works. I can drive a car, though, without knowing that. But you do need to know semi-technical at a higher level, which is what's predicted, how well, and what's done about it. At a it's arithmetic. It's a little bit of mechanics as far as like how you integrate a probability into a system. But again, it's semi-technical. So from the data scientist's point of view, it's high school. From the business professional's perspective, it's really technical, and they're prone to think, oh, well, this is why I have data scientists. I delegate all this stuff, all this technical stuff to the data scientist. So the hose and the faucet are failing to connect, right? We have these two parties there. There's this no man's land in between them. It's a vast gap, and it could be and there's lots of success stories, but the majority of new machine learning projects that are meant to drive new initiatives do fall into this trap and routinely fail to reach deployment because neither party are taking that initiative. But it really kind of only takes one person to at least make enough noise to ensure somebody's taking on the leadership. Most senior data scientists do understand that successful machine learning projects require a very specialized, particular business practice, process, paradigm, framework, discipline to run the project. Most junior data scientists have just been trained to crunch the numbers. And most business professionals do not even know that there doesn't require a specialized business practice, let alone know of any in particular. I'm trying to solve that now because I came up with this really cool buzzword, BizML. BizML, people, the business practice for running machine learning projects. So I coined the buzzword, and you don't have to credit me. I just want that word out there because we need to have a common vernacular to say, hey, look, there is a particular practice that we need to be driving beyond all the technical practices and all the technical tools and methodology. There needs to be an organizational paradigm.
Yeah. Okay. So I want to ask about machine learning. I'm sure most, if not virtually all people listening to this with this kind of interest understand what machine learning is. But just to go back to BizML and the difference between that and saying, let's hire some AI specialists, even if they're the same people that you're referring to, what's the difference in that conception of saying like, I want somebody for BizML versus I want AI experts, because that's the kind of buzzword that's floating around right now in most mainstream media, right? AI.
Well, if you say AI expert, you probably mean a data scientist. So again, it's the person who's familiar with the core technology. They know what basically the training data needs to look like and how to operate the machine learning software. You don't typically have to integrate or program any given machine learning method from scratch. There's a lot of software, including open source. They know what's available. They know how to leverage it. They know how to run the software on the data, create a model. And then they also know how to evaluate the model in very technical terms, the technical metrics, not so much translating into business metrics typically. So you've got the data scientist, and if you're posting a job and you say, I want a BizML specialist, maybe a little premature because the book's just coming out. But I think that term, hopefully, it's hard to coin a buzzword and hope that it catches on. But I work really hard on those 5 letters, people. So, let's make this happen. I think it should, and it must. So you're posting a job, it says BizML. Well, what does that mean? It probably means a data scientist who has given themselves a promotion, right? Somebody who has expanded their scope of view and said, you know what? I'm not going to just crunch the numbers. I'm going to ensure that we bridge this abominable communication gap and actually link up, connect, meet, click together with the business stakeholders in terms they understand, make sure they ramp up on that semi-technical understanding of exactly what this project's going to do, what's predicted, how well, and what to do about it.
Yeah, let's jump into something concrete to like highlight what it is that you're talking about. And I like the one of the intro stories you have or anecdotes is about package flow technology and UPS. And first, I was wondering if you could say a little bit for people who haven't seen the book, and then maybe we can dig into some of the specifics about that. Because like much of this book and others that are sort of similar in their content or their context, it seems so obvious as I'm reading it. And yet oftentimes these things fail. The vast majority, in fact, probably fail. Let's focus in on the UPS situation. Can you say a little bit about that and then how that applies to BizML?
Yeah, UPS is one of the 4 kind of main case studies that the book covers for examples. 2 of them are from my own consulting. One was a failed project, sort of the flagship of this failure syndrome I'm describing from my own practice for online dating. Another for online ad targeting, which was successful. And then also FICO targeting fraud detection. So the UPS story is that they predict deliveries in order to optimize the deliveries. So that's where they're using a predictive model. Who's going to receive a shipment? Which address, whether it's a business or a residential address, is going to receive a shipment tomorrow? That's a great idea. I can explain now, a little bit why they need to do that and how it optimizes. But just sort of the bottom line here is this is a great example project where when they first went to deployment, it did fail because they hadn't quite managed the change challenges. They hadn't conducted the right change management practice initially. They had underestimated, but not terribly underestimated in this case, but they had underestimated what it's going to take to actually instill the change and get the deployment to take effect. And then they went back, redid it, and improved. So here's the deal. At the shipping center, so this is sort of the last mile of delivery or last, dozen miles, whatever it is. The shipping center, they put them into the trucks. So what they have to do is plan, and then the way all the packages are going to be allocated to the trucks and then begin the loading overnight. But they need to start that before they're even aware of all the actual packages and deliveries. Some of them, because of systematic errors and other sources of uncertainty, they don't know about until later. So the only way to start planning with a full picture is to make predictions to augment. So you've got the known packages, and then you've got this augmented set of predicted packages. So now that can go into the planning system and make better, more optimal resource allocations, deciding which truck should get which packages exactly, which truck's going to cover exactly which geography based on what's now known and predicted. And that can be done overnight and done effectively. Trucks can get out in time in the morning. The bottom line is that doing that, and that's called package flow technology, in combination with a complementary system called Orion internally at UPS, which actually prescribes the driving routes for each individual truck. UPS across the US achieved 185 million miles of less driving a year. They saved 185 million miles, $350 plus million, 8 million gallons of fuel, and 185,000 metric tons of emissions saved annually by the improvements of those 2 combined systems. So, but here's what happened with the package flow technology, where you're changing the way and more optimally allocating the packages to trucks based on, in part, on predicted deliveries, is that they launched it and it was flopping. They weren't seeing the returns. The metrics were not going up. They weren't seeing the improvements that they expected. And it turned out that you had these truck loaders on the loading docks, that staff, who weren't really buying in. At first, they thought it sounded like a great idea, but then they kind of like went back to old habits. They had years of hard-earned wisdom, knowledge, and expertise about different addresses in their geographical region. Oh, well, these packages certainly should go together. So they would override the system way too often. So what they did was they circled back and they're like, look, we're going to have to instill this change with a little bit more authority and conviction and follow through. So they had several training personnel for each of these sites that would stay for weeks on end until the site demonstrated through scorecards that they were adhering systematically and very rarely overriding what the system said about which package goes to which truck. And it would reward and short-term successes because the long-term business metrics would take a little longer to accumulate. Ultimately, they had a staff of 700 in the end, of 700 personnel just for training that would temporarily be on these at these different sites. So that's how they achieved this win. That's how they pushed through the change. So taking a step back on what's the lesson learned here, any machine learning project that's meant to actually deliver value, which hopefully they all are, is a change management project. It's a business project with a business goal that uses machine learning and its predictions as a technical component. So maybe we should call it a business project that uses machine learning instead of calling it a machine learning project, which keeps the focus in the wrong place, which is the core technology rather than its deployment. So what happens is, so what that means is people don't quite realize. So change management's nothing new.
Mm-hmm.
But the problem is that people systematically don't quite recognize that machine learning, these they consider it a technical project, is actually a change management project, an operations improvement project, and it requires that change management discipline, which has been so well honed. It's just a matter of applying it.
Learn a proven approach for solving business problems with data in Pragmatic Institute's Business-Driven Data Analysis course. Elevate your impact by improving communication with stakeholders and delivering critical insights. Find out more and enroll at pragmaticinstitute.com/data. Yeah. And I mean, when you break it down like that, it's pretty amazing to think of, you have a classical, if you want to call it that, company that gets packages and loads them onto trucks and then drives around hoping that, they'll deliver them all on time. Then you have this newer approach that is, statistically amazing and going to save hundreds of millions of dollars. And yet it's not a no-brainer to roll that out. And we see that in more and more businesses, I think, as we start to hear about how they embraced ML or AI and then either went back or didn't have the success they expected. And oftentimes it's not necessarily the actual technical details. It's that human factor. So if you are working on, I imagine this is more than a one-person project, is to roll out something like that from, the conception. What do you recommend for people who are maybe akin to that kind of system where they have this amazing idea for, getting packages faster, saving what will ultimately be hundreds of millions of dollars, hundreds of millions of tons of pollution, or however that's measured. And yet, if you were to just say, give it to UPS and walk away, they would not see any change. How should people prepare for that when they're starting those kinds of projects?
Well, preparing for it is the purpose of the BizML practice. And whether you learn it from the book or hopefully it spreads around and becomes commonplace, the first step is to plan for the deployment. So the last step of the 6 steps is the deployment itself. But the first is to eke that out, flesh it out with the input and buy-in from stakeholders. So, the little story I just said about the huge story I just said about UPS is about where there was a challenge gaining buy-in from the workers who were loading the trucks. But you also need buy-in from the executives. And there's another chapter in the book covering that for the UPS story in particular. So that is to say, you need this full stack buy-in across the organization. That's kind of a joke because the word stack usually refers to a technical stack, but I'm talking about the organizational stack, right? From the executive down to the loading dock loader. You need to get buy-in at all sides. And that's why you start. It's backward planning. You start with exactly how is this thing going to deploy? What's our end goal? What type of improvement are we trying to get? We're trying to decrease the amount of driving miles or whatever the KPI is. Well, if we're going to do that, then how exactly do we need to change operations? How exactly can we improve which transactions our limited fraud detection team should actually look at? So you work backwards. That's going to be the change to the actual day-to-day operations. It's not business as usual. It's business now changed. And then, based on that, okay, what do we exactly need to predict? And that's actually step 2, is that defining that very specific prediction goal in all its nitty-gritty detail. And then that manifests into how the data is prepped, because it's the data preparation is actually where you actually manifest what should be predicted. The modeling part where it learns from the data is not where you specify what's to be predicted. It's actually in the data prep step. So we cover that. That's kind of the semi-technical type of stuff that business stakeholders need to wrap their head around so that they can participate in and witness and inform and ultimately buy into the overall project.
Yeah. I wonder if you could say something about where we are now in general, or maybe we can just focus on, let's say, the American economy or something, where we're hearing about ChatGPT and all of these advances with AI. We're hearing about more and more models that are going to be hopefully revolutionary. And yet we're also in the wake of, seeing what you mentioned in the book, how self-driving cars were absolutely going to be here by this year, probably. And yet we're not all being driven around in self-driving cars, in part because it was hyped up, but also that change was way more than we were expecting, or at least when some of the predictions about self-driving car technology, the idea of like changing the way that people use cars or the way that people use highways was a totally different challenge than seeing if a computer could recognize stop signs and pedestrians. And so the reason I asked about the cars is because it seems like we're at an inflection point where a lot of people are saying AI is going to change everything. What advice do you have, especially from the business perspective, of measuring that or understanding those kinds of claims that AI is going to revolutionize everything? And then thinking back about, self-driving cars, jetpacks, all of these things that we were sort of promised that never came. How do we know where we are now with the AI cycle? Where is there too much hype? Where is there maybe areas where, we should be ready for significant change in business?
Well, there's definitely too much hype. So let me try to qualify it. I love generative AI. The nerd in me is enamored with large language models. I was in natural language processing research group at Columbia before being a professor for 6 years. I never thought I'd see what it could do in my lifetime. And I'm incredibly excited. However, the world is about 10 times as excited as I am. The world's actually too excited. So here's how I would try to qualify it. And I think there's a good analogy there to self-driving cars, because in both cases, we're talking about amazing leaps in technology, but then the hype is basically over-promising on autonomy. And here's the deal. When you look at generative AI and its ability to write in natural language in a way that's seemingly human-like, even though it's more seemingly human-like than other use cases of machine learning, like the ones and it is a use case of machine learning at the core, by the way. But the other ones that I've been talking about, these sort of direct business, these are the ways to improve all the large scale operations, organizational decisions at that micro level, per case level. That's where you have potential autonomy. Let's block this credit card charge because it's probably fraudulent. So here's the deal. The increase in seemingly human-like, ironically, actually means less potential autonomy. So that is to say, you need to manually, as a human, proofread everything that these large language models write, right? And we all kind of know that. And people use the word hallucinate, which kind of reverses the narrative from how it should be. If the world is shocked by how often the thing is wrong, I'm actually not only shocked by the world's shock, I'm shocked about how often it's right. Because at the core, these fundamental large language models are not designed or optimized for higher order goals like being correct or sound or knowing the right answer in most cases. They do turn out to do quite an amazingly good job, but if the stakes are high, or if you don't already know the answer, you can't just rely on it and expect it to be correct. Now, I'm not saying it'll never get there, but the sort of misconception is that improvement to what we have now is just a product development issue. It's not. It's an R&D issue. It's a research project, even for a limited domain, like conversing about wines and the history of wines and the different kinds of wines, or a chatbot that helps a service repair person who's an expert in washing machine repair out in the field and has a particular question, knowing that it's going to know the right answer most of the time and that most of what it says is going to be correct. And however you define the metrics, which at this point is sort of the Wild West and it's TBA. But once you define them and now you want to optimize them and get the thing to not only talk in a seemingly human-like manner the way it already does, but also be correct and sound with a high enough confidence and frequency that everybody's comfortable. That's a research project, which means we don't know when we're going to get there. It could be in 5 years and it could be in 30 years, even with a limited domain, even within a very limited scope kind of topic area that the thing would be able to chat about. So, the jury's still out. That doesn't mean there's no value in language models by any means. I mean, there's plenty of value so long as you're willing to understand there needs to be a human in the loop at each iteration, right? At each output. A customer service agent who's running a chat room could have a chatbot suggest something, but they're going to review that new paragraph before they copy and paste it manually at each step. that's sort of where I think that recognition is a little sobering. I think it's a splash of cold water, much needed, and it might temper the hype and sort of help align where there is potential value with that particular use of machine learning.
Yeah, it makes me think about, that earlier story about UPS. From our perspective today, I think it seems so obvious with, more modern technologies, the fact that we're all using Google Maps or some kind of equivalent, and the fact that we see Amazon trucks all the time, delivering in seemingly, incredible speeds compared to earlier, like a decade ago. And so when we look back and say, of course, you should have made that change to these kinds of systems at UPS and similar places, that is easy in retrospect. But at the time, I can imagine what would it have looked like if somebody said, hey, we want to make UPS full of autonomous driving vehicles, and it's going to save billions of dollars in fees and income and all of these things that we're going to reduce by doing autonomous vehicles. And we kind of know from what we were just talking about that probably if UPS had gone in that direction and embraced autonomous vehicles, they may have gone bankrupt because that technology just hasn't gotten to the stage where they could implement that. So going back to a decision where right now maybe somebody has a really smart machine learning or data analyst saying, hey, we should go in this direction. How do you know, or what should you look for? And obviously I'm not asking you to predict the future, but if you're, a C-suite executive who gets this opportunity and somebody is saying, we have this new technology for you, how do you know whether it's a case where, yeah, this is going to speed up, it's going to lower pollution and it's going to speed up deliveries, or it's going to lead us to bankruptcy because we're embracing things too fast? I can see how C-suite would be not sure of that in the present. What should they be looking out for to make sure that they do embrace those kinds of meaningful changes that machine learning can bring, but not overpromised and hyped up solutions that, could lead to, financial collapse?
That's a great question. I think I'll answer that in 3 parts as far as how an executive should be able to look at a proposal and say, look, is this actually realistic or is it just hype? One is, how precise is it predicting? So in general, there's a lot for most of these use cases in business, not all of them, but a lot of them, it's something that's intrinsically unpredictable with high confidence and precision. So which customer is going to click, buy, lie, or die in the subtitle of my first book, Predictive Analytics? Who's going to commit fraud? Who's going to cancel as a subscriber? A lot of these are, and healthcare outcomes. A lot of these are about outcomes pertaining to individual humans or businesses, or which satellite's going to run out of battery more quickly. These are all real world deployed use cases of machine learning, but none of them are things, unless you're a magic crystal ball, you can't be predicting with incredible high precision and confidence, but you can be predicting a lot better than guessing. Now, there's other cases where it's like, hey, is there a traffic light in this picture? Yes or no? And both humans and now, in more recent years, computers can predict that extremely well. Or we do use the word predict, even though technically you're not predicting the future. But is this healthcare patient having this diagnosis? Is there a picture of a cat? Is this transaction fraudulent? Whatever. You still use the word predict in the vernacular. So don't be unrealistic about the level of prediction when it comes down to that. The second of 3 prongs is that what degree of autonomy is expected. So if you're automatically blocking credit card charges that might be fraudulent, the false positive cost is real because the customer is, that's where the system says this is fraud, but it actually isn't. That type of error. And the customer is inconvenienced. And that does turn into a real cost because that customer is more prone to stop using your bank's credit card or maybe canceling it entirely, right? Or at least if it happens too often. So there is a real cost, but it's a manageable one considering the win of correctly blocking fraud. So there's that balance. And that's a place where you can have full autonomy, where the operations of the business are run completely automatically based on the output predicted by the model. In other cases where it's high stake about housing, healthcare, law enforcement, incarceration decisions, there's so many places and self-driving cars, where lives are on the line, and it's a completely different level of both expectations, understanding the metrics of how well it needs to perform before we're comfortable, and sort of the assimilation into society and the sort of incremental steps of getting it deployed. Don't underestimate the sort of organizational or societal practice and process needed as you incrementally move towards deployment. And then the third one is just sort of basically the claims, right? I mean, the first of these three was how well does it predict? But in the case of large language models, it's sort of like, how smart is it? And you can define that in a lot of different ways. But just because it seems human-like and how well it writes does not mean, and just because it passes tests that were designed to evaluate humans, like the bar exam, doesn't mean that it has general human level capabilities or that it's approaching them. There is no evidence that it is, even though it looks like it. So don't drink the Kool-Aid, right? Don't think, hey, it's getting human level. It's getting amazing. It's going to be able to do anything any second just because the demo is unbelievably cool, which it is.
Yeah. Yeah. And I guess that's part of it too, right? Is that we're seeing some amazing examples of how things can be deployed, but usually they're in very specific situations that have been very, curated for an audience or something like that. And where it will actually work is a different question. So I guess as we start to wrap up and as we think about what you've highlighted, which I think is so important, right? The difference between just creating some kind of model on the data science side and asking for a data science team on a executive side, where that gap has to be filled in, is huge, especially right now when I think a lot of people are making like really elevated claims that they can't necessarily support. And when people are rightfully weary of investing, potentially millions or billions of dollars in something that may work or may not work. So as we start to prepare for changes in our future that seem inevitable, let's start with data scientists. So you've already said that if data scientists and related people start thinking more about business problems, they're going to be in a much better situation. How would you recommend people listening to this kind of prepare? So maybe that's a certain kind of education. Maybe that's gaining a certain kind of experience, or maybe there's other ways. But if people are listening to this and they're, pretty well suited to do those calculations, to create those machine learning projects mathematically, what should they be doing to help them improve in a BizML sense?
Well, I mean, I have to plug the book again, because that's
in addition to reading the book, of course.
Yeah, well, I mean, there's not a lot out there, which is why I wrote the book. There's not, it's the need for a commonly understood practice that I'm calling BizML. The need for it is certainly growing in the zeitgeist. And I think that data scientists in general understand there needs to be a business objective, but really fleshing that out into the full scale of what it takes. How do you play out that whole practice in terms that are meaningful to the business stakeholders as far as, what's going to be deployed, how, what exactly are you predicting to that end very precisely? How do you define the metrics? And then therefore, exactly what data do you need? The core rocket science part doesn't come until step 5 of the 6-step practice, right? So this is a practice and a book about machine learning that doesn't really get into the machine learning part until towards the end. But that makes sense because really it's got to be an organizational or business project first with a operational goal first. And then you're designing and using the technology to meet those needs and to achieve that goal. So that reorientation and, I know only too well that as a data scientist, your comfort zone for good reason is the number crunching. And which algorithm should I use, this ensemble method or that ensemble method? Mm-hmm. And I'm looking at the area under the curve, which by the way, data scientists, I just have to say, area under the curve is just as much a red herring as accuracy. Accuracy is very commonly used even amongst non-data scientists, but both of them are equally problematic in that they really do not directly map to the business value. You've got to take a hard look at your metrics and exactly how you're measuring and optimizing the model and how it's being evaluated and then reported in its potential business value to the stakeholders. And meanwhile, the carrot at the end of the stick of the whole project is how that deployment, after you deploy, yes, you have to monitor. But for the time being, let's at least get to value-driven deployment in the first place. So that, as I'm formulating it, is the culmination. That's the carrot at the end of the stick for the whole project. The whole point is we're trying to design the whole thing so that once you actually do integrate, operationalize it, it's actually capturing value for the business.
What about the other side of things? As you've already mentioned, people, I like that analogy of driving a car, right? You don't need to know all of the intricacies of a combustion engine, but you need to know how to accelerate and how to steer and things like that in a car. You don't need to know the technical aspects of an engine. Similarly, if we're talking about, let's say, like project managers or product leads or all of these positions that are related but not doing the data science themselves, how should they better prepare themselves to work in these projects?
Yeah, I mean, and that's sort of a common misconception. I don't need to learn. I don't need to look under the hood in order to drive a car, which is true, but that the analogy applies. You do need a lot of expertise to drive a car. Maybe not about how the engine works, but you need to know about momentum and friction, the rules of the road, what other drivers expect from you and what you should expect in their behavior. You need a lot of expertise. And likewise, if you're driving a machine learning project that's going to succeed, you need that semi-technical knowledge, which in a nutshell is what's predicted, how well, and what's done about it. You need to dive into those things. It's semi-technical. It's not the rocket science, but it's also not, a 1-hour keynote presentation. It's a book. So the book actually not only outlines the playbook itself, but at the same time ramps up non-technical readers on exactly the amount of semi-technical understanding they need.
I wonder, I'm thinking about the idea of a prompt engineer, for example, as a position that no one really thought about 5 years ago. And now we're seeing calls for prompt engineers because of changes in the way things are being organized. Is there going to be some kind of love child between the machine learning expert and the product manager that we don't know about now? But as things become more common, as this issue becomes more commonly understood that you're talking about, are we going to see, maybe it will be that buzzword of BizML people or professionals, but are there going to be new roles? And here, feel free to just imagine these things. I'm not asking for a prediction. I will call you on. But what can we expect?
Yeah, no, it's definitely already happening. And I'm definitely not the only person talking about the problem that we're addressing here, or even the ways in which it needs to be solved. And so there's a couple names for that. The only one coming to mind is machine learning business liaison. So there are people who play that role, try to play it explicitly, bridge that gap. Again, this is not a failing field. It's just that it could be succeeding a heck of a lot more than it is in actually achieving value, right? I mean, it does succeed in gaining goodwill and hype, but being able to sweep where it does fail under the rug and ride on the wave and energy of hype is not sustainable, right? We need to translate things so that the minority who are kind of getting it right from the get-go, everyone else learns those best practices. Yeah, so that's definitely going to be part of it. There will be new job titles. That's a great question.
Yeah. And will it be something that you imagine, at least with major organizations, whatever it was, 10 years ago, people started talking about how you need a machine learning or you need a data science, suite or group of people. And all the organizations seem to be hiring those within the last decade or so because they knew how important it was. Do you predict or see changes in how that is? Maybe everybody needs a change management guru in their organization, or how do you see that unfolding in mid to large organizations?
That's a great question, man. I mean, will it be a new title or will it be a new trend within an existing title? You've got chief data analytics officer. Will their mandate become more clear as far as, measuring deployment success, this kind of thing? Because the fact is, and we see this in our surveys of data scientists, half the time these projects literally, there's no measure of their deployed success.
Mm-hmm.
It's sort of like, hey, this is the best of the best technology and we're using it so we can sleep well at night. But no, it's not intrinsically valuable. Its value is only in how it's deployed.
Yeah. I mean, that's a lot to think about, both from a sort of technical perspective of how we can improve operations and change, but also from a strategic perspective of how people should be expected to better understand what's going on, not just to hire smart data scientists, but to better understand what that actually entails. So lots to think about in this. And then, of course, anyone interested can check out the AI Playbook. Eric, where do you suggest, other than grabbing your book, where should people look for you and your work and follow along?
Well, if you just go to the website for the book, you can find out everything, and it's bizml.com. So that's bizml.com. We'll get you to the website for the book, and there's a bunch of other pages about me and how to contact me and information like that. There's also a special there. If you pre-order the hardcover or ebook, you can get an advanced immediate copy of the audiobook version for free.
Awesome. So lots of exciting things happening. And I think this playbook helps people make sense of that. And this conversation, I think, also helped me and listeners make sense of it. So Eric, I have to just really thank you again for being on the show and for giving us some of your wisdom.
Yeah, my pleasure. Thanks for having me, Chris. And thanks for all the great questions.